Right, we should be live. I don't know if this will update itself a couple of seconds later. There we are. We are live. All right, cool. Um, Welcome to the stream. Super short stream. I am on a clock. I have only about half an hour to do this, maybe a little bit more, but I have to leave immediately after because I have some IRL stuff to attend to. But we will try and attempt this because I will not be able to stream later tonight. I'll try and complete like the solution to day 15. That's all I'm trying to do. I'm not gonna solve day 16 right now. I'm gonna try and complete part 2 of day 15. There is exactly one thing that I want to try, like exactly one solution that I want to try, um, which occurred to me last night. I actually gave a blurb of that in my Discord. Yeah, so essentially based on what we were trying to do yesterday, the super long algorithm, etc., etc. I found a way by which we can actually massively simplify that. I think that should work. That is my assumption. I wouldn't say assumption. That is my sort of idea is that that should work. Like, I think we shouldn't have a problem with getting that to run. The main thing is that will involve rewriting a good portion of what we've tried. We will try and do that first, right? We'll try and do that. Let us actually get started, right? So, okay, all I want to do is at the start, right? So here are the differences, right? So what we're going to do is we're going to use this priority queue as a dumping ground, more or less, right? What I realized was that anything which has int.max value is basically going to go to the bottom of the queue anyway, and is not going to be the next one that's picked up, right? We never pick up. This is like an important thing to note in Dijkstra, is like especially for like a sort of a fully connected graph, as it were, like, in this case, like, because we don't really have like any section of the graph that's actually completely broken off, right? So at any given point of time we will have, and let me just run the music. um yeah, I hope that's not too loud. I'm gonna almost completely silence it for myself because I need to hear myself think. But anyway, here's what I realized, right? So the priority queue that we have, we don't actually have to pump in anything into that. We don't have to put in anything except uh the n- the values that we are currently looking to add, right? That's pretty much all we have to add to it. We don't have to add anything else. So we can actually highly simplify what we are trying to do here. We can like super simplify that. We can make this like really short, relatively speaking. The thing is, anything which is infinity which we are dumping in is going to go to the bottom, and so we never actually have to update the value of any node in the priority queue. We can simply insert a new node. As long as we have a way of comparing nodes, which we do, we can simply insert a new node which contains the updated value of the risk, right? So anywhere where you have the value of the risk reduces by taking a specific path, the updated risk is basically that we take the risk map, and if it's less than that, we update the risk map, and then we insert this updated risk into the queue, right? The way I'm thinking about it is we don't need to remove anything from it. So that's how we make it faster, right? In fact, the way I think about it right now, it could be a lot simpler, but okay, what we're going to do is we are actually going to simplify this massively. I am not going to add anything in a loop at all. I'm actually just going to put in yeah, so initially we do have to put in everything in the risk map, maybe. No, the risk map also, we don't need to do any of that stuff. We can do this, right? So in the init block, we can take the risk map and dot with default. We have to return a risk, right? So the risk by default is int dot max value. So if anything that isn't entered, we enter the risk like of risk int dot max value, right? And the only thing we want to do is we want to add in risk map of 0 comma 0, 0 to 0 in this case, right? Since it's a pair, is equal to 0, right? We want to do that. And we also want to add that into optimal risk. So optimal risk dot or plus equal to, I think dot add will work as plus equal to, I'm pretty sure. Plus equal to this node, which where we pass in, we need a pair, which is of course 0 to 0, right? That's our pair of vertices. And the risk which we're going to pass in for that is 0, right? And this is all we are going to do to start. All we are going to do to start. We will update the optimal risk only at these points, right? So that's basically what we're going to do. Fairly simple. I think this should work and should solve our problems, right? So while the optimal risk is not empty, we need to keep doing this. We will never actually hit the not empty condition because we will have the old nodes in there. So we will actually never hit the not empty condition, which is fine because we expect to hit this guy anyway. It's fine. We'll keep this as is, right? But it doesn't matter. The point is like we will do a return. Sorry, where's the return? We will hit the return condition anyway, because we will hit is equal to this, right? So we'll hit that anyway at some point, right? That's okay. That's okay. We don't have to worry about that. Um, so vertex comma risk, navigating through this, while optimal risk is not empty, we pick up the lowest one, right? So dot poll gets us the lowest one because at this point, like we have that. I'm assuming is the right comparator. If the comparator is incorrect, it'll be a huge problem for us. Let's just look up the priority queue example, right? Uh, let's look up the priority queue example for comparator example. That's kind of what I need, right? I just want to see through comparator in Java. Oh, geeks for geeks, fuck. Okay, but it's fine. Let's quickly look at this. Please try your approach. What is the question? Fuck me. This website is so trash. Regular queue, each element has a priority. High priority is served. Comparator. Comparator orders its elements according to the specified comparator. That's the question. We need to do scanner, student, comparator. Student is what? Implements comparator student, compare student 1, student 2, CGPA is less, we return 1, descending order of CGPA. So it returns, if it's less, it returns 1. Yeah, so in other words, this is s1.cgpa minus s2.cgpa, right? Isn't that what it returns? Like, wait, so Java comparator, should it always return a 1 minus 1, etc.? Total ordering on some, comparators can be passed to a sort method. Uh, Zero, caution should be used. Inconsistent ordering. So suppose a sorted set has some shit, some shit. Sorted set will violate the general contract. A dot equals B, C dot compare A, comma B not equal to 0 to an empty tree set with comparator C. The second add operation will return true. A and B are not equivalent from the tree's perspective. What? Uh, Java.io.serializable. Wait. 1 second. We just need to the compare method returns a negative integer 0 or positive as the first argument is less than, greater than, or equal to or greater than the second argument. Okay, so correct. So in our case, if it's less than, it will return a negative number. So it's just a minus b that we have to do. That's fine. That's fine. I think that's correct. Um, that is correct. Okay, cool. So if we do that, we will basically pull out 0, comma 0 initially. If the vertex, so this is the return condition, that's fine. And now what we're going to do is for every neighbor in this list, in vertex.neighbors, we are first checking the risk levels. Like, so we make sure that the neighbor is valid, that we have a valid neighbor. If you don't have a valid neighbor, we just skip it, right? If we do have a valid neighbor, right? So at this point, we do have a valid neighbor. We get the neighbor node equals optimal risk first or null. Wait, I don't think we need to do this, right? Neighbor node equals optimal risk first or null. We don't need to do this. We can actually get it out of the risk map, right? What do we need this for? Neighbor node equals optimal risk first or null. Oh, to remove it. That's the only place where it's used. That's the only place where it's used. We have to see that it's unvisited, right? Oh, that's a little bit of a problem for us, isn't it? We have to make sure it's unvisited in a certain sense. Mm, only if it is unvisited. Oh, was that the issue we had last time? Oh, fuck me. In that case, it still won't work, right? Because if we have already visited a specific thing, well, technically we can do that as well, right? Technically we can do that as well. It dot vertex double equals neighbor. So normally speaking, let's go back to the algorithm. We can do that as well. I think we'll need a third data structure for that. Let's go back to the algorithm. Dijkstra's algorithm, there it is. If we go back to this, fuck the priority queue, because the priority queue that they are talking about is actually a Fibonacci heap, which we don't have in Java unless we implement it ourselves, which is not something I want to do. So if we just talk about this, create vertex at q. For each vertex v in graph, distance of v is infinity, previous of v is undefined. Add, while q is not empty, we pull this, right? Still in q, which means where do we add stuff to q? Oh, at the start. We add everything, don't we? But we remove stuff from queue only when we remove stuff from queue only at this time, right? When we do this, we remove stuff from queue. So this is the visited stuff. We have to make sure it's not in the visited set. That is, it's unvisited as such, right? There we go. Yeah. So that should be fairly straightforward, right? We should be able to update that pretty easily. Because at this point, what we do is u in vertex we remove. So we do this poll, right, to kind of get the vertex. If you just keep a set list, a set of visited vertices, I think that should be fine, right? So val visited um, vertices equals mutable set of int to int. Oh, right. That should be a pair. Fuck, pair int comma int, right? That's basically what that is. And now all we need to do is, so this is a visitor vertices. I think like pair int comma int, I should type alias it to something else, so it becomes a lot easier to read. I should probably type alias that to vertex. Let's do that. Pair of int comma int. Um, can I type alias the entire thing using a refactor? Introduce parameter type alias. There we go. Vertex. Yes, I would want to replace all occurrences. There we go. Okay. So, beautiful set of vertex. Fantastic. We should have run this like ages ago. I don't know why I was writing pair of int comma int everywhere. That was stupid. Cool. So, we have vertex. All right. Vertex comma risk. Vertex is this, return the risk. Okay, cool. All that is fine. Visited vertices at this point 0 comma 0 to 0. Um, we need to do the poll. Optimal risk is not empty. We do this and we mark it as visited, right? We mark it as visited. So we just say here that, and we can technically do while, so visited vertices plus equal to vertex, right? We can technically do while visited vertices dot size is less than, is less than the total set, but it's fine. Like either way, we will hit the final sort of barrier as it were, right? So we for neighbor in vertex dot neighbors. So we do the continue. So this is the thing. This is the first check. Okay. Or or uh, neighbor in visited vertices. Then we continue. All right. Right. We do that. Type alias. We should make this private. And we should probably move this down if possible. Control shift down. Oh fuck me. Control X. Back. That's a lot of stuff. I just like to have my type aliases at the end. I know that that's probably not convention, but I like to have my type aliases at the end. All right. So we do this. So to skip the thing if it's visited, right? So for every neighbor that is still in queue, basically, we do this, right? So now we don't need to do this first or null, any of this nonsense, right? We don't have to do any of that. Back. If neighbor node not equal to null, we don't have to do any of that either. So this is an unvisited thing as such, right? And we don't have to remove either. We can just add it. So plus equal to, I think dot add. Can I replace it with plus equal to? There we go. Optimal risk plus equal to updated risk. Node of neighbor updated risk. Updated risk equals risk plus risk levels neighbor first, neighbor second. Update risk less than risk map of neighbor double exclamation point. I think at this point, yeah, we don't have to do a double exclamation point either. We kind of have to just do off neighbor because we have with default, right? We have a with default. So risk map, we can just do that. There we go. Is less than that, right? And we kind of get yeah. I think this should work. This should work, right? Let's just run the tests. If this works, I can end the stream in like 10 minutes, and that would be the fastest that I have ever had an idea work, but I don't know. Let's see. Yeah, of course, it'll take a little bit of time for the test to start the first time because, like, again, we haven't run any tests today, so IntelliJ would have just cleared his caches, invalidated everything. God, what's up? Dude, I have, oh my god, it's working. But part two is still taking time. It's working though. Solve part one is fine. 652 was the correct answer, I believe. Like nine out of 10, like, oh yeah, I have implemented a new algorithm by the way. The same thing what I was spamming in Discord at like 4 a.m. yesterday. Dude, I wasn't able to think about anything else today, man. I was literally at work. Half the day I was thinking about this problem because it wasn't, that idea wasn't leaving my head. I was like, oh my God, I should have done this. I should have done this. It's so clear. It's so fucking easy. But the problem is, it's still taking time to run part two. That's the weird part. Yeah, I just wanted to try this. Honestly, I just wanted to try this. If this didn't work over and like, correct some small issues, but if it didn't work, then obviously I was just gonna leave. People leave time, but yeah, because we have the year-end party coming up, like in 45 minutes, and it'll take me half an hour to get there. Today's problem feels way out of my depth. Oh my fucking god. Okay, if this feels way out of your depth, I'm fucked. Okay, that's not a good sign. That's not a good sign at all. Let's see. Can we go into Advent of Code? Um, Day 15. No, I'm not gonna even look at parts day 16 right now. One failed. Heap space. Oh, okay, out of memory. So it ran out of memory. Okay, 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 okay. It ran out of memory, bro. That's not great news, but it did solve the other parts. It did solve everything except part two. It ran out of memory. Uh, okay, let's see. Oh my God. Dude, look at this. It finished. It actually terminated, which is not something I had expected at all, but we are getting an out of memory error. Uh, in a minute 15. Which I can work with. Yeah, throw more memory. No, wait. Let's see. How do we optimize memory wise, right? Okay, look at my fucking solution, right? This is so awesome. I just feel like I was being stupid. Okay, yeah, I think we're gonna have to do with what Chris suggested yesterday, like what he mentioned yesterday. I think we're gonna have to do that. I think this will not work for us. I think we're gonna have to not generate the graph. We are gonna have to alter this algorithm, but I think it's very doable. I think it's very doable now because we have actually cleaned this up heavily. Okay, look, what we are doing right now is super simple, all right? The risk map, we start with nothing. We just start with the zero node, and we optimal risk is the priority queue, which contains the nodes 0 to 0 is the vertex, and the risk is 0. I also made a nice little type alias called vertex for pair to int comma int, so the code becomes way cleaner, all right? All this I did in like 5 minutes of time. I've been live for 15 minutes in total, all right? This took me no time at all, honestly, but notice what we've done. Okay, the first thing we've done is, of course, if optimal risk is not empty, we start processing, all right. um we get the optimal risk, and we get whatever is the optimal risk so far, sort of like for the visited vertex, right, plus equal to vertex. We have to keep this extra set because we cannot use this like a map, unfortunately, right? This is not a map, so we need something which we can query 1:1, right? uh yeah, we need a thing we can query like 1:1. We also need a thing which we can query for the risk so far, which is again supposed to be a map. So this is a map, sort of. This is a set. It's a map without values, just keys. This has to be a map, and this is a priority queue, right? And I can keep all of that stuff. I can basically just check if the neighbor is in visited vertices, then I continue, I skip it, right? This, of course, is the check to make sure that this neighbor is valid, because sometimes it kind of goes out of bounds. So this check will check if it's out of bounds or not, right? So if it's out of bounds, that's the part we might need to change now, to get it within memory constraints. Throw more memory, I think, is doable as well. I just don't know, because I don't have a profiler. I don't know how much memory it is taking right now. Um, I feel like we should be able to do it. Throw more memory, huh? Man, okay. Is there is there a way I can pass in, let's see, modify run config, modify options, add VM options. Uh, yeah, should I just give it like 2 gigs of memory and see what happens? Mm, what are these? Mm, okay. It's been a long time since I did that part, so I'm pretty sure it's the XMX thing. Um, Wait, so Java, increase runtime memory. Oh, you know this? Okay. This is not something like most people. Yeah, heap size. Yeah, I suppose that's all we need to do. Okay. 2048, let's fucking do it. Let's fucking do it. I hope I have like 2 gigs of memory, to be honest. Do I have, wait, let me just because I have 400 plus tabs open. So Performance. Eh, yeah, let's try it. Why not? I don't have it right now, but I think like Firefox will probably give up some tabs. In fact, I can do one thing. I can do one thing. Let's do auto tab discard. Discard all of the tabs. Uh-oh. That discards the chat as well, but all right, we got that back. I think that should be sufficient. 2048M. Apply. Okay, let's run you. I think this will take over a minute to run. In the worst case, RIP stream. I hope not. I seriously hope not. But okay, let's see. Actually, I don't know if it's stream that will die or something else because like I'm pretty sure I've got OBS on like relatively high priority. But that actually I might have done that setting on my previous PC and not this one. But also it might take a little bit less memory because we haven't changed anything, and I think like this is configured like IntelliJ will try to cache stuff, but I don't know for sure. Let's see. If it if it runs out of heap memory again, like fine, we'll just you know like, cry about it, I guess. Okay, so what I've done, right? Let me just explain what I've done. What I've done is very simple. I realized, right? This was the epiphany I had last night. I don't need to remove nodes from the optimal risk priority queue. I don't need to remove anything, right? And maybe that's the problem with the memory actually right now. But I don't need to remove anything from the from the priority queue. The reason I don't need to remove nodes from the priority queue is because if something is inserted and it has a high risk, and I replace it with a node which has low risk, I don't need to replace it. I can just that high risk one will bubble down. It'll go down in the priority queue. It won't. Yeah, it's still out of memory error. Um, did it run with um scan to get full insights? Is that? But I mean, it's that's yeah. I mean, I kind of know why it's taking a lot of memory. But at the same time, okay, but the problem is if we do the wraparound thing, it still won't solve the fundamental problem we have with the priority queue, which I'm assuming is the largest data structure we have right now. The priority queue will still not be solved because the priority queue still has to store every node. The only thing we can do is we don't have to create a massive risk levels. That's the only thing. Like this thing, we don't have to create like a massive risk levels thing. This doesn't have to be big. This can be small. Yeah. Hmm. We are running out of memory. I don't know if that helped or not. Modify run configuration XMX2048. Mm, what's hyphen EA? JVM memory duplicate. XMS. Initial Java heap size and XMX is the maximum Java heap size. So the initial heap size, if we set it to like a half MB. What's up, man? Apply. Okay. Let's rerun you. Um, we have gotten what's up, Mad Flash? We have gotten the most efficient algorithm so far. It's running all the other tests instantly. It's only on the actual output for part two. It is fucking up because it's running out of memory. So it's a memory limitation now, not a CPU one. It is still sort of like CPU wise also not great. Like it takes above a minute, but it runs out of memory in about a minute, which is a problem. So we still don't know what the actual like sort of right now the bottleneck is obviously the memory, but we don't know where the actual limits lie. So yeah, hopefully this like yeah. That's why would it require that much memory though? I suppose objects are just heavier in a certain sense. Mm, maybe Kotlin slash Java is the wrong language to do this, to be honest, but it's a possibility. It's just not something I can work around right now because I just did want to do all of this in Kotlin. Okay, so the thing I figured is you don't have to remove anything from optimal risk. You don't have to remove any nodes from it because if you remove a node, you have to scan for the node because we don't actually have a pointer to the node. We don't know where the node is sitting in the priority queue, and the priority queue's memory locations obviously keep shuffling around, right? Like as you insert and delete stuff, it keeps shuffling around things internally. Like it bubbles up and moves them down, etc. We kind of know this, the sift up, sift down operations. It kind of does that internally. We don't know the exact memory location of any node in optimal risk. Yeah, it's still running out of memory. Okay. Yeah, that's unfortunate. If I run everything else, it kind of runs super quick, doesn't it? Like if I run this, everything is passing that too. Like everything is passing. We don't have a problem with anything passing or like well, part one does take 984 milliseconds, which is not bad. Which is not bad. 115 milliseconds. Okay, everything works. Everything works. Scaled risk works on the test input. Everything works. It's only the production input which has like massive problems. The thing is, memory wise, since every node in the priority queue is still unique, I don't think it will help because we still have to keep inserting stuff into the priority queue. If we start removing nodes from the priority queue, what happens is that um, yeah, like if we start removing nodes from the priority queue, we will basically. Can we remove the bottommost node from the priority queue? Is that an operation we can do in Java? Once we add this node, can we remove the bottommost node? Optimal risk dot remove. I want to remove the last node because I know that the last node will be once we update a node, we have inserted one node which contains an updated risk. So one of the bottommost nodes will basically have something that's bad. The value is wrong for it, right? Would that always be true? Mm, yes, I think it will. I think it will. Because we are always inserting, whenever we insert one, we have to remove one, and the one that has to be removed will basically be at the bottom, right? I feel like that should be a doable operation, but what does dot remove do? Oh, it removes the top one, removes the head of the queue. Can we remove the tail of the queue? Do we have a priority DQ? Java DQ a priority queue would definitely be. No, that's not what I want. FIFO. Uh, no. There has to be a way, but I don't want to implement my own priority queue, bro. That's the problem. That's what I'm trying to do here. I'm trying not to implement my own. Rust, I think any other language will do better memory-wise right now for this question. Like for sure, for sure, for sure. Mm, memory optimization. Fuck me. Okay, this is the problem. Default initial capacity. Mm, comparator. Blah blah blah. Add clear comparator. RDQ remove bottom element. There is a remove I, not at the top of the priority queue. There is. Mm, fuck. This is wait. Java priority queue. I have to put the language. Remove method. Removing tail element of the priority queue. Tail element. Yeah, there we go. Last element. What the fuck? No, that's not. That's not ideal. No easy way. Copy elements from the original to the new except the last. Eh, eh, Queue wrapper that enforces bounding. Inverting comparator, PR's use cases, he needs the head. We do have a remove I. We have this option. Like, don't we? No, 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 no. We have to pass in a node. Do we have fuck? Yeah, no, if it's running out of memory, I don't know what to do now. So our implementation is correct, basically. Our implementation is just correct. We just don't have a way of optimizing the memory because I know we are inserting a lot of stuff into optimal risk that's not necessary at all. Everything else does need to stay the way it is. Like visited vertices will have a maximum size of 500 cross 500 in this case. We need to keep track of that. We definitely need to keep track of that. Risk map, we need to keep track of that as well. We can't do without either of these. But optimal risk is where I kind of have a thing. I feel like we should be able to get rid of that. Maybe pairs are a problem. Should I not be using pairs? Should I just be using, I don't know. Mm, wait, close out the tabs. Should I not be using pairs? Fuck me. Uh, I still consider this a partial success. I still consider this a partial success, like in the sense that we actually have something that we know for sure works, and it worked first try. Like we literally didn't have to do anything beyond just clean up the code slightly and make that small difference, which is basically that we check visited as a separate data structure, which is fine, and we update risk map over here, right? We update risk map and then we oh wait, maybe oh oh fuck me. This is the problem. This is the problem. We are okay. Maybe now we won't run out of memory. Maybe now we won't run out of memory. We forgot to. Okay, so we didn't actually. Both of these weren't part of the if statement. This is why, man. Okay, this is why my one of the senior engineers like at Amazon in my old team where I used to work like was he would always like put a review comment if I wrote an if statement without braces. I forgot the braces around the if statement. I think that's what the problem is. So it was always adding a note to optimal risk. Now it should be highly bounded in comparison, and we should hopefully. Okay, I'm hoping again. This is all fingers crossed moments because I have no idea. I have no idea if this will work or not. Mad Flash, can you fit it? Oh my fucking god! That was the problem! Oh my god! Oh my god! Oh my god! That was instant! Holy shit! Ah! Okay. Where? Shut. Fuck. Oh my fucking god! This question fucked us for so long! Holy shit! Okay, dude, okay. The problem, optimal risk was always adding a node. That's why we were running out of memory. It was always adding a node in every fucking neighbor, every loop. Every single loop, it was adding a node. Like for every neighbor. It was adding nodes and adding nodes and adding nodes. But it doesn't matter because only the ones which actually have the real updated risk value would get picked up, right? Because that's how the priority queue works. No wonder it was taking so long and oh my fucking god. Now part 1 runs in 29 milliseconds. That's so short. And part 2 runs in 956, which was how long part 1 was taking. Oh my god. Oh my god. Oh my god. Okay. Shit. Well, I guess that's about it. That's about it. What in fuck? Okay, that was so quick. That was so quick. Like we just you saw what the problem was, right? Optimal risk was not in the if statement. That's all. We moved this in and that's it. That's it. It finished the question. We solved it. That was so fast. Also like a couple of cleanups here and there, and now it's so much neater. It's so much neater. Initialization is super quick, has only one node in it, doesn't have all the nodes. We aren't using any nested loops, we aren't using any scans, we aren't using any crap. This is the data structure. This is very interesting, by the way, because I think a lot of people don't actually know how you would implement Dijkstra's in a way that's doable, like neatly, right? And the trick here is really that optimal risk. You just kind of keep dumping values into it because the ones which are going to get picked up will bubble to the top. So the old value of the risk, right, which was there. So updated risk less than risk map of neighbor. So initially risk map of neighbor was the same value which was present in optimal risk, right? But we just add the updated risk in. We don't have to delete anything from it. We don't have to delete anything from it as long as you have the memory. If you have the memory, you don't have to delete jack shit from it because to delete something from it, you have to find the node and that takes a linear scan. That takes a linear scan. You don't have to find the node and delete anything. You can just keep adding to it. It's fine up until a crazy amount of memory. Today's problem involves a bunch of bit. Oh, you guys are talking about today's problem. Okay, I will solve today's problem tomorrow. I have zero time right now. I'm literally completely out of time. I will solve today's problem tomorrow. I really just wanted to go and stream and do this because I was losing my mind. I was actually legitimately losing my mind. I was thinking about this problem the entire day. right? Not trying to solve it. I solved this last night. Basically, I did the exact same solution what I was talking about last night, but I wasn't able to get it out of my head. I was like, I need to solve this. I need to solve this. I was thinking of solving it off stream, in fact, because I was like, okay, yeah, I probably won't have the time to stream, but I can always just check if the solution works. Then I was like, fuck it, let's see. If it doesn't work, it's gonna fail live. It nearly did. It nearly did. But we solved it. We solved it. It took us a little bit of time, and I think on the private leaderboards, I'm still pretty bad. Obviously, I'm not going to check the public one because like that's going to be depressing. Um, yeah, I'm still on top. I'm still on top. Fuck you, Sam. Okay. Anyway, cool. That's about it. From me for today. Super super short stream. Like I said, I do need to leave. I'll catch you guys tomorrow. Tomorrow morning I will be streaming. Tomorrow evening also I will be streaming. So tomorrow morning I will solve day 16's question, and hopefully, and evening I will solve day 17. If it's bit manipulation, it's gonna be a little bit of a rough ride in Kotlin. It's gonna be a little bit of a problem. Um, if it's a lot of manipulations, like we can do some bit manipulation. I think this will be a good opportunity to learn or relearn really how you do bit manipulation in Java and Kotlin. You look shook. I am shook. If you're talking about me, I am shook. I didn't expect. I didn't. When we had the out of memory problem, I didn't expect that the solution for that would be that simple. That it would be such a simple mistake that I made. I just didn't have braces around the if. I just didn't have braces around the if. It's a good thing I noticed that. Mostly because when I did Control Alt L, it actually just moved this back here. Like, sorry, it just shift tabbed. It moved it here. So when I did Control Alt L, it had moved it back. So I was like, oh fuck, that's not part of the if statement. I didn't expect to solve it this quick. Anyway, I do have to leave. This was fun, way more fun than I expected. I actually took a little bit of time off work to do this, to be honest, because normally I would be working even at this time. But yeah, I literally just went like, yeah, no, I have some shit I need to do, and yeah, that's about it. That was the stuff I needed to do. It's done. It is done. Oh my fucking god, this question was so long, so insane. Why did Dijkstra's take me this long to implement? Holy shit. I think it was because like initially I tried deriving it by myself, but I'm not Edsker's Dijkstra. I don't have any fucking clue how to do it. Anyway, yeah, I will be ending stream now, so you guys can actually continue on my Discord, I guess. Uh, I don't know if I want to see this. Oh no, I don't want to see this. Okay. Cool. I will look at day 16's question. I'll just leave this open. I will take a look at this tomorrow morning. That's when we will be solving this. Hopefully tomorrow morning before day 17's question comes out, which should happen in I don't know how many hours. 15 hours. So 15 hours would be so that's 12 hours. This is 7 p.m. That's 7 a.m. plus 3 10-ish, 10:30 around. Yeah, whatever. So hopefully we're able to solve it before that question comes out. So I will try to go live tomorrow morning, 9 a.m. 9 a.m. around. I say this. There's no guarantee I'll wake up, but yeah, I will try my hardest to do that because I do want to solve this question before the next one comes out. So anyway, um, God, well, good luck with that. If you solve the question successfully, it'll be amazing because you can guide me slash laugh at me on the next stream. So anyway, thanks for sticking around, guys. I will catch you guys in the next one. Bye bye.